Okay, this is Jason Stutzman speaking for EGEN Group A7. We tested prototype 1 on Wednesday, and overall it went pretty well, but there's some areas in which we can improve. So first off, let's talk about the rover. Our client is the colonist, so we're working on a rover, not a racer. So our idea was to design something more rugged that could withstand more challenging terrain, with the knowledge that it didn't need to be maybe as light and fast as other groups of rovers. So as a consequence of this, we have very low RPM and high torque 12-volt motors, which excelled at the hill climb even without a running start. We had no issues climbing a 36-degree ramp, but when we tried to go up a 40-degree ramp, we didn't have enough weight on the front of the rover compared to the back of it, so it tipped backward. It seemed like we still had enough torque, so if we fix the weight distribution problem, we should be able to go up even steeper. Weight distribution was also an issue when we were driving on the floor norm, since our front tires, through which we were steering, weren't making optimal contact with the ground. So we we temporarily fixed the problem. We weighted down the front by duct taping a heavy object, and then drove and turned smoothly with no issues, but we'll need a more permanent and intentional solution than this for Proto 2. For the driving laps, we moved slowly but steadily with no issues, and after the 5 minutes of laps, our motors were 70 degrees Fahrenheit, which is roughly room temperature, which should mean well for the rover if it were put into an actual mission. We do need a better off-road chassis and higher clearance if we're going to get up rugged terrain, as well as we need to reduce the size of the body so that it's appropriately sized for the tunnel. So we're going to work on these things for Proto 2. For the bog, the 6-inch deck build went well for it being Proto 1. It seated into the bog extremely well. Outside of the bog, the deck withheld 11 pounds, and inside the bog, it held the tested 5 pounds, but we didn't test higher than that. This should be more than enough to hold the rover, even though the rover is one of the heaviest, if not the heaviest in the class. Unfortunately, the deck was unknowingly built in violation of part of the code, since the sizes of some of the beams and joists were slightly off, so we're working to correct that for Proto 2. For the swamp, it's a work in progress. We were able to test some of the performance metrics. The system curves were created correctly. The flow rate for the unrestricted green pump was measured to be 3.5 GPM, and the flow rate for the unrestricted black pump was 4.5 GPM. The flow rate of the black pump wasn't reduced as much as we needed, so the first thing we're trying is adding another orifice plate to see how that affects the flow. And then for the PCB, since we have the colonist client, I devised a system in which a time of flight laser, it's just a laser that bounces off of objects and then back at the sensor to measure distances, is both horizontally and vertically rotated in order to make a rudimentary scan of the rover's surroundings, similar to like a 3D scanner. We're also pairing this with a temperature and humidity sensor. Through testing, each part is at an appropriate voltage and current according to its spec sheet, and I've been able to code and run all of it successfully with the Arduino microcontroller. I'm working on a MATLAB visualization of the distance data, and myself and the other rover designers are going to make a much sturdier mounting system for the rotating servos with some counterweight. So a lot of this is being routed through the PCB. I just need to make the circuit maker board design and get it ordered before we run out of time for manufacturing and shipping. So that's it. Thanks.